Okay. Oh, well, we have 4 lectures left. I think 4 or 5. 4.
I have a professor for my Tuesday, Thursday class at 4.
I think it's 4. I think today, Tuesday we'll wrap up the forestry component. Oh, and then I think we have one on mine lands. I have one on parks management strategies. That's it. So y'all are recovering from the assault that was the test. I am going to do my best to go through the math that you all have with a fine-tooth comb and give you as many points as I can. That's going to take me time. All right. I'm hoping to have everything graded over Thanksgiving break. Bear with me. It's a lot. You ever find your key?
No, I had to go get a copy made.
Other issues that have arisen that don't really impact you that much, but impact me drastically. Tuesday's lecture is going to most likely occur over Zoom because my heating system went out and they're installing a new one on Tuesday. That was the only day they could do it. So given that it's supposed to be 19 degrees Monday, I'm going to hopefully not be frozen solid. But it depends on their installation speed. If we can have it in person, I will. Unfortunately, you have a lab that we're just out of time that you have to have on Tuesday. We can't cancel it. If that didn't exist, we'd probably be doing Tuesday's lecture over Zoom anyway, just so you could be at home if you wanted to be. So we have a lab. I strongly recommend your attendance at the lab because we're starting to get into birds, smaller birds. You all are adults and can make your own decisions. Sarah would appreciate your attendance because she's going to go through the effort to put everything out. Outside of that, everyone got a handout? Okay. This is more because we're going to go through a quiz at the end of the lecture here, so I want to make sure you have that in front of you so you can try to answer the questions. It's a practice quiz. It's just for making sure you grasp the concept of snags and their aging because it's important relative to wildlife species and the value they possess at each of those decaying stages. Does anyone have any questions before we get into the lecture? Okay, good. All right, so we're going to get a little bit more into the stand level forest management strategies and considerations for wildlife, certain tactics that can be employed. There's mostly just concepts and how you approach everything. And I'll talk a little bit about why that is. Remember that, in general, we're trying to meet some or all of a species requirements for survival and reproduction. What are those things? We spent a couple classes on them. What are the 3 major things? What?
Food, water, cover space.
Food, water, cover space, right? So you all are studying many species, and you know that not everything is in 2D, but also 3D. And therefore, as you approach a forest stand, right, that unique kind of similar soil content, slope aspect that would produce similar vegetation in an area, how you manage that stand, you need to be thinking on multiple levels. So forest floor, the shrub layer, the understory, midstory, and then finally the canopy. What is being provided in each of those scenarios? And given what species you're managing for, how is that meeting the goals you need to meet for that species to have success in that area? So all of this really comes down to what are you managing for? All of your goals are going to be species specific, or usually, because about, for forests in Kentucky, 91% of them are privately owned. So it's going to be geared towards the landowner goals. You may have public land that you're actually gearing it towards certain habitat types that are rare, glades, so on, certain species that may be threatened or endangered, or groups of species that are in decline, especially things like birds, neotropical migrants that are attached to a certain habitat that's in decline. Those plans that are created, those management goals, generally are associated with habitat. Okay? It's not as much population level. It's more, build it and they will come. Build it, you improve their carrying capacity, food resources, survival. That's the overall idea behind it. So you focus on those requirements to help improve the situation for those species. And it really can, it can vary drastically as you approach each individual one, right? So we talked a lot about grouse in this class and needing early successional forests. So going in and logging out sections of a stand or the entire stand to produce that habitat, it would be vastly different than if you're managing. Aiden, do you know what species this is? Those who've had herpetology?
From here, it looks like deeper.
So it's close.
Woodcock?
No, it's a course, mountain course. Yeah, bad. You can't really see the and size reference. Why we can't do species ID for labs over the internet, right? Or talking about bears and the size of management strategy you have for bears. And we're going to get into landscape level management and concepts associated with that next class. But we're going to focus on the small scale here. Every situation you approach is going to be unique. And this is where it gets very difficult. We can come up with prescriptions of management strategies for certain general situations. And a lot of times people are like, oh, what should I do for deer in my property? Or what should I do for birds in my property? Well, if you don't know what their property looks like, you can't say, well, you want to increase your food species or that, because if it's this versus this, it's completely different in how you approach managing for a suite of species or individual species. Because what are we really looking at here? So I told you to approach a forest based on its vertical components. This one is pretty well stacked all the way through, right? If you are a ground dwelling wildlife species, are you probably in good shape here? No. What about this? They just did a timber harvest. What would you expect? There's a couple trees on the ground. It's a shelter wood, well, a little less than a shelter wood. So expectations of plans and outcomes of plans are hard to relay to landowners. In addition, telling them a certain prescription is what they need to do generally is also very hard for them to grasp because everything is different. And if this thing was full of invasive species on the bottom, it complicates it even more. So you have stilt grass or multiflora rose or something like that there, or kudzu, even worse. So in essence, whenever you're talking about wildlife management, you have to get your eyes on what you're managing for in most situations, or at least have data from someone who went out and collected it to tell you what it actually looks like. So you can do things like visual obscurity here, and it would basically tell you that everything is visible below 20 meters. And if you, after you get the experience of doing that, you think that that's what this looks like. Here, you can only see like 5 meters in each direction. If you're lucky, you would know that the structure is all there. Okay. We, in essence, in terms of habitat management and especially forests, are using our understanding of succession, or, plant succession to our advantage. We know that consistently, if you have any disturbance, you start off with bare earth, you get lichens initially, very early pioneer plants, that eventually transitions to forbs, to grasses and other weeds, into some other mixed herbaceous plants. Over time, you start seeing shrubs kick in. Then you get some pioneer tree species, tulip poplars, sumac, cedars, depending on where you are. We pretty much know how it works. Okay, so within each of those, here's the transition, right? Within each of those, we have an understanding of what species benefit from what stage. So if we're managing for rabbits and we're managing an area that's in grasslands, we start getting a lot of shrubs present. We know we have to set it back to make sure it remains rabbit habitat. Because if we let it go, they're not going to be able to use it as well. And all of a sudden, it's not rabbit habitat anymore. So how we set it back matters. In this sense, it was cut. So we went from this to this. So it's a drastic change. You can have smaller disturbance events or different disturbance events that can go from here to here. It doesn't have to wait till the end. You can do things like prescribed fire. We can disc an area. We can mow it. Okay. You can put goats in there in some situations where you have an extreme herbivore disturbance. So knowing how disturbance events actually impact succession is important. We have a pretty good grasp on that, to the extent where we know that a clear cut and then a fire cause two different types of successional change. So this is the extreme fire. Think Gatlinburg a couple years ago, extreme fire. Or out west on when we get the big fires. It changes how that advances in both, sometimes the species, but also the timeline. Okay. So when you talk habitat management to a landowner, this one is pretty handy to use. It's especially handy to use if you have pictures of the types of habitat that you get at each stage, so that you can be like, look, you need a little bit of this, this, and this for these species. Do you have that on your landscape? If all you have is this, you need a disturbance event. By the way, you can cut it and make money off it to get to the habitat you want. It's a sales pitch. You become a used car salesman. So foresters do the same thing. But if your ultimate goal is conservation of species, how you get there on a private landowner and how many acres you can switch into good habitat matters for those species. Yes.
It's the only way, like if you have a mature forest, the only way you can really change is if you go clear cut and not go full timber because it's like the age.
So
Like directly, I'm saying instead of going clear cut and then waiting for your shrubs and saplings, that kind of thing.
well, so we have various, that's a good question. So we have various tools. So you can be at a mature forest and do certain situations that get you back to here,
Okay.
right? You can have harvest strategies that don't set you all the way back. We talked about the shelter wood harvest, the seed tree harvest. Those don't take all the major trees out of the equation, right? They take some, and what you end up having is an intermixing of this type of habitat within 2-3 years in that area.
Okay.
You don't get the big grasslands. This really happens when you open those clear cuts, regeneration cuts up to where you get that style of habitat.
Okay.
All right. Yes.
So my question's a little off topic, but it's 91% of Kentucky land is privately owned.
91% of Kentucky forests.
Is that the norm or the exception for most states?
In the east, most of the east is locked up in private property. The west is a lot more public property. Think BLM lands, national forests. So it has a lot to do with the value of that land, right? You go to BLM lands in Wyoming, it's basically just grass that's barely growing. So no one's really wants it. So it, ranchers want it because they can put a bunch of cattle on it, but that's, they don't want to pay for it to own it. Yeah.
So I have 3 questions.
Okay.
Is Nevada by percentage, Alaska by space, correct?
I believe so. I think Nevada is like 90, some 95% public,
Yeah.
some ungodly amount.
Yeah.
And Alaska, yeah, millions and millions and millions, tens of millions of acres.
And then, so my 3rd question is like, what's the pros and cons of letting ranchers on that land? Like, doesn't that cause like ecosystem collapse? Because they're not necessarily, it's not their land, so they're not like managing it in a way of like, oh, I need to be able to like rotate my cattle back onto this necessarily.
So in the ideal situation, what that is doing is creating a disturbance event to keep the grassland going and healthy, because those grasslands evolved with bison, right? So they evolved with that natural disturbance event of having a large herbivore going through. What we see happening a lot now in like Oklahoma and Nebraska especially is they have a lot of areas that were grasslands that haven't had a lot of herbivore activity on them, that are now having encroachment issues with cedar trees. And they're losing their grasslands because they don't have that event. Fire is also not a big part of that picture, which helps set that back too.
Yeah.
So the advantage is that in a way, the resource is there. It can support it if done correctly. So why not allow economic benefit to occur?
Yeah.
If done correctly. Overstocking, access to riparian areas, all those things have degradation issues. So in theory, yes. In practical action, maybe.
And then how does the wild horse population, the invasive wild horse population?
The non-native herbivore that exists in the West. So that's a human dimensions issue. Are all of you aware of the wild horse issue, or they would not know what I'm talking about with horses in the West? Okay. So Rachel, there's a large population of wild horses in the West primarily on BLM lands. There is a community of folks that are very pro-horse and believe that horses belong there. They were part of our founding of our country in the West, how the West was won, and like seeing them on the landscape. The population is unchecked. They're incredibly large herbivore with basically no predators that is eating themselves out of house and home, along with all the native wildlife and grazing cattle. So BLM on an annual basis actually rounds up horses and sells them to many entities.
That's where you get like the wild Mustang show up all
Yeah.
the time.
They'll also pay you to take.
Yes, so so the paying part came about because no one wanted the horses, and it was a solution to sending them to Mexico for butchering. That was an incentive of, we'll work with you, we'll try to pay people to take them and rehab them to be domesticated. Yes, it's a situation, and it is a major issue if you're out West trying to deal with it. We constantly have our national, international conferences talk about wild horse management for 3 days straight, every conference. It's a huge problem because they have a major impact on the landscape, whether they're there or not, for legal, not legal, so on. We are about dealing with that issue here now because of horses that are let go for free forage in Southeast Kentucky on the minelands. And now they are reproducing. So we're concerned about what that may mean here, because there's a lot of politics. And those on the horse side, pro-horse side, there's a lot of money associated with those folks, which complicates things in general. So where that goes, who knows?
One of the big solutions that I hear about right now is Colorado State's using the same thing that they did with elk management, where they were controlling the elk. They're trying to bird control the horses.
Yeah, so I can tell you right now, it doesn't work. It also didn't work on elk. It doesn't work on white-tailed deer. You all were at Toledo. Those little elk that were there, the babies. Both cows in that pen were treated 3 months last fall with birth control. That is under a complete controlled situation with a vet that comes in and treats them. The drug does not work. Apply that to a natural setting where it's very difficult to even run into an animal close enough to dart it twice. Cornell has done work in multiple locations, actually tying the tubes of deer on their own, land grant institutional property, also on Long Island. And, deer move around. So new deer come in and they populate. They've removed all the bucks from an island and found out that if there's like 20 does running around an island, a buck will swim across an ocean to get to those does and will get the job done for reproduction. So the lesson we should have learned from Jurassic Park should be applied to everything associated with birth control. Mother Nature finds a way. I don't know if you all saw the news about the condors. They just proved that condors reproduce asexually.
The California ones that.
Yes.
went extinct?
They have proven that 2 of the baby condors were basically clones of mom. Kind of cool, right?
I was reading the article on that. Apparently pigeons and turkeys too.
There is belief that it happens, yes. So the dispersal strategy for most birds is the opposite of mammals, where the females will disperse because they're laying eggs. And if you think about several of the herps too, they can hold sperm. And if they can hold sperm from multiple males, you have a genetic variation that's already included in your clutch to start a new population without the issues of genetic bottlenecks. Pretty cool, huh? So you can have a clutch of turkey eggs of like 14 eggs, and every single one of those is actually not related outside of mom. They're just half siblings. But now it may be that like they're complete clones. So, I don't remember if the juveniles, I'm pretty sure the juveniles were females. It'd be really astounding if they were clones and all of a sudden were switching sexes. That would be some Jurassic Park shit. So anyway, back to disturbance. To give you an idea of, other examples of how you would look at or approach management, thinking of succession, we're looking at what is required from those species. A stand, though it may have a management strategy in place, may only fit one requirement, okay? So, and we're gonna get into this more on Tuesday. You may need to have multiple types of successional stages meet close together to meet the requirements of a single species. So here's our timber doodle, our woodcock, who needs open grasslands to sing, pole type, early successional 5 to 10-year-old timber for cover, and a little bit older growth, young forest for brooding habitat for the young to move around through it and feed. Old forest, mature forest isn't really used, but you have basically 30-year-old trees down to no trees that you have to provide in a single area for that species. Okay, so it can be complicated. Other things to think about is biomass production. Where do you get the most vegetation produced that's available for the animals to consume, especially for herbivores? So obviously you have a lot larger trees, potentially more biomass available in a given area. However, if it's in the top of the canopy, it's not really available. So for herbivores like deer, having young early successional forests, grasslands, and trees is actually the most amount of food because it's all accessible to them in this area. As soon as it gets older, you may get mass production, which is a food item for them, providing biomass, but it could be inconsistent or seasonal. So generally, if it's an herbivore that is going to browse on trees or plants, you're going to get the most bang for your buck with things in the young tree and earlier stage. Okay. Now, back to this, every situation is unique. How do you provide those things depends, but there are certain management tools that we can use. So say you're in this situation and you know the landowner all of a sudden wants to have rough grass or wants to have songbirds, all of the songbirds, not just the canopy songbirds. How do you provide habitat quickly to meet their management goals while still knowing that it's going to take time for a larger scale? Well, we have some things we can do. For example, you may go in there and cut down larger trees that have no economic value and position them to create habitat structures that meet requirements while that vegetation will grow, right? So it may take 3 to 5 years to provide natural cover, but you can build wildlife piles like this, stack up everything that you cut down on top of it, and all of a sudden it's acting as a same kind of escape cover they would need. How these are structured is larger parts of the tree in the bottom, which creates gaps in there for things like rabbits and mice and everything else to run under, while not creating large enough gaps for things like bobcats and coyotes and foxes to get after them, or owls or hawks to fly into. So you just basically pile it up. Songbirds, mice, snakes, all of these things are very readily used. And the good thing is it's kind of filling that void while you're waiting for that natural succession to take hold. Other examples of things you can do, we talked a little bit about this in the last class, with things like crop tree release, where you're actually trying to encourage the growth of certain trees, usually for timber production reasons, right? Because it allows that tree to fill gaps where the sun comes in, and they'll expand out. Big bursts of resources, they'll grow quickly, right? 10 to 20 years, you all of a sudden have a better tree timber wise. But during that time, because you have an expanding canopy, you also get things like more mass production, acorns, hickory nuts, those kind of things. Whereas if these are all non-mass producing trees, you got rid of something that's not providing food and getting more space to something that is. You also, while that tree is expanding its branches, you do get sunlight on the floor, forest floor, which will get a burst of growth there too. Okay. Transition zones, and we're going to talk more about this on Tuesday, but transition zones between two habitat types are called what? Well, it's literally right. Edges, okay? Edges can be problematic for certain species, favored by others. Predators really love edges. They follow them because it allows them to efficiently hunt. Also, because you usually have two types of habitats, you have two types of prey sources potentially. So they may be more efficient hunters. One of the things you can do to favor prey, which a lot of our game species and non-game species are prey, right? So things we care about from the hunting standpoint, rabbits, quail, deer, they get eaten a lot. Especially things like fawns, not so much adult deer, but fawns. So creating softer edges makes hunting and finding prey more difficult for predators overall. And how we can do that is basically, instead of having this abrupt change where it's forest to an ag field, you can remove amounts of trees from the edge of the forest back. So you let some sunlight in. Usually you start by removing about 75% the first 5 to 10 yards or meters. Then you go 50%, 25%, 0. So it creates this transition where you kind of have whatever this ag field or a pasture or whatever, where you have some grasslands and shrubs, more shrubs and trees, finally smaller trees into the mature forest. So you're providing transitional cover, edge, if this is adjacent to a crop field, give them safe access to a food source, okay? Without, really causing a lot of change in the habitat structure. In addition, because you have a different light reaching this area, you're going to get slightly different tree species than the interior forest. So you'll get things like persimmons, plums sometimes. So a lot more of our soft mass producing species, which increases food availability. Yeah.
So do you select which trees to remove based on size and species?
Yes. Yeah. Based on your goals. So you may have, so you may be in an area that the landowner likes seeing bats. You may have had a shagbark hickory right here. You might keep that shagbark hickory because it gives easy access for that bat to forage out in the field. Okay. All right. I'm going to transition into a little bit of talk about snag management, mostly because we haven't really touched on it. Does anyone know what a snag is? Yes. It's a dead or dying tree, right? Well, as you can see from the paper, it actually includes live trees by definition. It's just they're level 1 snags. Why we care about them is because they provide a resource that some species and wildlife depend heavily on, right? So think woodpeckers, especially larger woodpeckers that are cavity nesters that create their own cavities. It's a lot easier to create a cavity in a dead or dying tree than it is a live hardwood tree. In addition, you have a lot of insect species that are working in dying trees that are not present in live trees that are all food sources. Those, work their way up to things like bats, brown creepers, woodpeckers, and so on. So you get not only food sources, you have cavities potentially there. As that bark is falling off, it creates openings and unique thermal situations that bats thrive in. Bats are really looking for microclimatic temperatures. And the more bark you have falling off, the more they get access to the conditions they need. So we spent a lot of time talking about snags. The forestry folks back there consider them a nuisance and potential danger to their activities and like to see them gone. And rightfully so. The number of people that have trees fall on them while they're working in the forest is high. We just had one of the professionals at Penn State. It was a faculty member that just retired that died from a tree falling on. So it's something that's real and serious, and why they all wear hard hats. And why we probably should wear hard hats most of the time, but we don't. So when we start thinking about snags and who's using snags and not just snags, right? So this affiliated woodpeckers on a live tree, but we have two main users of cavities. So a cavity is basically just a hole in the tree. You have the creator of the cavity, okay, and then the secondary users. There's far more of these than there are of those. So having woodpeckers in a forest is important because there's downhill benefits to all these guys. So this gives you an idea of, some of our primary users. And we've got, we have 6 woodpecker species in Kentucky, 7, I think 6 or 7. That are actively working to create the cavities that are used. We probably have 30-ish plus secondary users that are highly dependent on the existence of those primary users. Some of them are actually rather large species that we never think of. You know, wood ducks, several waterfowl species are actually cavity nesters. And not so much here in Kentucky, the wood duck is, but common goldeyes, mergansers, especially in the boreal forest, rely heavily on the existence of those cavities. But other things that we do have here, things like kestrels, a couple of our owl species do need to have those larger cavities present in the landscape and in the forest. Now, because of this being recognized, it's always a question of, well, how many snags do I need present in a forest to get those benefits? To make sure all of those woodpeckers have what they need in terms of food resources, access to substrate, they can create cavities. This is not a formula I will expect you to be able to calculate. It just know it exists, okay? And it came down to looking at trying to figure this out for our, really a lot of time was spent in the Pacific Northwest forest to come up with a model to help folks determine snags in that area. And it was pushed by a gentleman and eventually became the only wildlife biologist to head up the Forest Service. And what it comes down to is they came up with some estimates, and part of that, you know, includes looking at and understanding what each of the species of woodpecker in area need for territory, how much overlap in those areas do they allow between individuals. So that's where you get into approximate territory size, maximum number of pairs within 100 acres, because thinking out west, usually stands there are hundreds of acres. And you can see that, you know, you're looking at trying basically come up with an understanding of each species, what they need. And then there's also this idea that snags come in various sizes, so you need to have certain things over certain requirements to actually get the benefit. And, you know, calculate it out and came up with estimates for each species. Yes.
Is the number of cavities per pair per year, how much they make or how many they need?
Both. So once a cavity is made, they can reuse it, right? So it's not automatically gone. So they may only make so many per year, but this is really what is required in terms of the number of cavities that they will move. So like they'll move around and relocate. Some, you know, some don't at all. And it's really odd that there's like, it's not a two. It's either one or a three. It's kind of weird. So it's more if you're going through and counting whole cavities, which you may do, you have to make sure that's that number of cavities that are present, one way or another. Yeah.
Do they need to use cavities that they excavated, or can they use like natural holes in trees?
Yes. Sometimes they start as natural holes in trees and they make it the way they want. So a lot of times you will not find a hole in a tree that is exactly bellowed out with a little drop in that the chicks can't fall out, you know. You do see that sometimes with owl species or secondary producers, where they're going to find a hole and use it because there may not be an actual cavity created by a woodpecker. So they're a little less picky, but woodpeckers will put the finishing touches on those things. All right. So the big thing taking this is there's an understanding and the ability to calculate how many snags you may need given the species that are present in an area. A lot goes into that calculation. It's based in science in terms of home range, territory, and space use requirements and reproductive requirements. All right. The big thing to take from about snags is if you're managing 4 snags, larger snags are going to persist longer just because it takes longer for them to break down. Usually larger snags will also be used by more species because there's more surface area and technically potentially more niches there present for them to be used. Overall, naturally snags, usually because of disease, disturbance events, trees die off for all various reasons, somewhere around 5 to 10% of trees are in some stage of dying in a forest. The next time you go for a hike, take a look around and see how many snags you can find. You'll be surprised when you start looking at how much dead wood there is in a forest. Spatially, snags do not necessarily occur equally across the landscape. You can have clumped events. It may be an insect outbreak or a fire that kills trees off, and you get a lot of snags in one location. You may naturally just have the competing nature of trees kills trees a little bit more evenly across the landscape. But clumping can occur, and evenly distributed snags can both occur. What we like to say in general is you should have somewhere around 2 to 4 snags per acre on a property or forest. That's like as rule of thumb as we can get.
For animals that use snags, do they care what species the tree was before?
It depends. A lot of that has to do more with the nature of the structure of the tree, like shagbark hickories. So dying shagbark hickory has a lot more bark, softer wood obviously can be cavities can be created in softwood a little bit easier than hardwood. So in that sense, yes. There's also different species of trees will persist longer as snags as well. Dr. Lackey had done some work looking at various tree species in the Pacific Northwest and how long they'll stay as roost trees as they die. And we do see a decline as the trees age and the snag ages, a decline in use and survivorship of those trees and the species themselves, or the use of those trees as snags. All right. That gets into this idea of things like legacy structures, where you may have certain snags that are heavily used by species and this is where bat management really comes in, where roost selection, because this snag of tree is in a certain climatic situation, it fits what they need perfectly, more so than most trees around it. So it becomes a legacy tree. So you get maternal colonies that will keep reusing areas. So we deal with that on a local level with things like Indiana bat or northern long-eared bat, where they will actually have maternity colonies on properties. And we have an understanding where a lot of those are. And we work with landowners to make sure that if they do a harvest, that those things stay in place because of their value. That's kind of the ideal situation of applying the Endangered Species Act to management on properties. Yeah.
Can you penalize, like, because you ignore, like, oh.
Absolutely. Yes. So so for bats, so if they're going to do a forest harvest here in Kentucky, when they write up that plan, there are certain zones that are designated as potential Indiana bat, northern long-eared bat areas. The person that's putting that harvest together needs to look into that, and they go to a level of, is there a colony present? Is there situations where I need to be looking for said species? So it's that layer of work that the businesses and entities don't like. That's the ideal situation. But yes, penalties, they cut that tree down, and yeah, they're supposed to be penalties. All right. So give you an idea of that clump distribution of what it can look like. So this slide, I'm going to move forward. Beetle damage, complete loss of those trees in that one area. And this, in many ways, so this does not happen that often, but to get that regeneration clear cut naturally, this is one of the few situations where it happens, right? So you have dead trees. There's no canopy cover left. So you have complete sunlight on the ground. So this would act like a natural clear cut in terms of regeneration. All right. And what that looks like from the bottom is not a comfortable hiking experience. If you know anything, it's also like walking around in much of northern Kentucky right now with ash trees. If you walk through the woods, you're constantly seeing dead ash trees. Because there's like 60 to 70% of the canopy can be made of ash. But in terms of dead and dying trees, you can see there's regrowth is already happening on the ground level. What even distribution kind of looks like, you can see there's a snag here, there. So they're just kind of popping up. This probably would not meet the expectation of 2 snags per acre, but it's there. They happen. They're much more spread out with live vegetation around. All right, you all got this snag classification sheet, and there's a reason why you would classify a snag, right? So just like succession in terms of plant growth and the movement of plant species, snags deteriorate in a kind of known way. In many instances, if you know the climate, you can actually put an age and timeline to how many years it'll take to get to it. The same holds true for our down woody debris here. So of course, woody debris, decay class, so logs on the ground. This is something where, like, if you're managing for herps or insects, this becomes an issue. Okay, you want to make sure you have certain amounts of coarse woody debris on the ground. Anyway, so this is on a scale of 1 to 9, and there's characteristics that put them in that setting. Okay. This is a lot for your softwood trees, your conifers. Hardwoods have a little bit different situation in terms of how they deteriorate. But for the most part, even in hardwoods, we kind of use this scale of 1 to 9. Okay. So stage 1 is basically just a live tree. All right. The second stage is where we start seeing parts of the tree start dying. Usually that happens closer to the top when you start having branches that don't have leaves on them, which in essence, these branches are acting like a regular tree snag. They're just on a smaller scale.
Can a tree go from stage 2 back to stage 1?
So in that situation, if this tree, so this is all disease caused, the tree is able to overcome it, it'll generally lose those branches and become basically a live tree again, right? So yes, in that situation it can. The third stage is the tree is basically dead, all right, but it's still standing and may have some vegetation hanging on, but more than likely it still has all of its branches, or almost all of its branches. Stage 4 is stage 3. Oh yeah, stage 3 is usually when we start seeing a lot more wildlife use as a snag. Initially, it's those that are able to take advantage of, say, bark just starting to peel just a little bit. Insects start taking over, so there's more food there. So it's also when technically the interior part of the tree may start softening up, so it's easier to make cavities. Stage 4, we start seeing loss of some limbs and potentially some of the bark. 5, we see a lot more bark falling off, and usually there's very few limbs left, if any. Okay. 6, we start losing height. But generally, you're estimating it's about 2/3 or more of the height is remaining. Okay. 7, we're down to about half. 8, not much left. All right. And 9 is basically the stump is finally. Okay. All of these stages have different values to different species. So for the most part, though, when we say snags and needing snags, we're looking at stage 3 to 9. Really, though, if you're trying to manage 4 snags, you're looking at 3 to 6 for time's sake, because by the time you get to 7 and 8, they're not gonna be around much longer. Okay? Questions on that?
How long is this cycle?
It depends on climate and what you have insect wise around that eats trees, fungus, so everything that makes trees become soil again, what's around and how much is there. It takes longer in the north for it to break down than it does in the south. So usually, though, you have a pretty good idea within the area that you may work or manage how long it takes. Just may take a year or two to get it, but I would say to go from 3 to 7 here, you're looking at 5 to 10 years, if not more. So one of the things to keep in mind is this idea of den trees. This can apply to things like bats, but also can apply to much larger animals like bears. So having them around, it was actually one of the things that limited black bear recovery in Mississippi was there wasn't enough large trees that they could hibernate in or go into torpor through the winter. So they were going out and killing large trees and creating the cavities for the bears to crawl into to hibernate. That was one of the things that was a limiting factor for them. But they can be very rare. So just think about how often you come across a giant 20 dBH plus tree that's hollow. Doesn't happen very often. So preserving them can be pretty important. And unfortunately, because they're not common and use on them and creating them can be difficult, and use levels of wildlife can be difficult to understand, we don't have a lot of recommendations on how to manage them. The bigger thing is if you have it, you don't want to encourage people to lose it. So what that can look like is, you could have large structures that are hollow all the way up. Could just be a point in the bottom of the tree where they access, or vice versa, where bears actually like to climb in from the top and go down. Really important to a lot of bat species. Also used heavily by things like raccoons, squirrels, fishers, pine martens, so on and so forth. Owls, if there's hollow, not 2 feet. They can happen in various locations, not just in forests, but really important in terms of things like flooded bottomlands, especially because for bats, this is high quality foraging. So immediate access for a den tree right to the foraging area is good for them, both for their survival and their ability to eat a lot of food quickly. Okay. So how do you then create said trees or den trees or snags if you're lacking them? Say you have an incredibly healthy forest with no snags present. You can do a couple things. Most though, the easiest way to do is you kill the tree. You can do it with herbicide, spray it, the tree dies. It'll start progressing through 1 through 3 really quickly, but then 4 through 8, 9 slowly. You can girdle it, so you're basically cutting off nutrient flow up the tree, and this is probably the most common way of doing it for many, because you don't have to do the herbicide. Try to do a foliar spray on this tree. Jimmy, you want to volunteer to do that? No, it's almost impossible. So if you girdle it, you're cutting off nutrient flow and that tree will die. This takes longer than a foliar spray, but it's still very efficient. Okay. And notice that it's actually a pretty large band. Trees will recover if it's just a little, so requires a little bit of effort. This is actually put in place over this small wetland for bats. That's why that's done like that there. All right, questions on that? Okay. The next thing we can do, if you want, is, and this may come up in your last lecture exam, is just what stage is this tree? right? So image wise, I'm gonna give you an image, tell me what stage these trees are. You guys want to go through the quiz real quick? All right. You guys have a cheat sheet in front of you, so this should be pretty quick. 1 through 9, what do you think? Who thinks 2, 3, 4, 5, 6? All right, we'll stop there. I would say this is probably between a 3, or it is a 3, well, getting into the 4. Okay, it's got a lot of branches left on the one side. So 4, I would think you have probably about a third or a quarter of those branches left before you got to that. Start off 4, 5, 6. Very good. Got 2 here. So you got number 3 and number 4. So 3, we'll start with 4, 5, 6, 7, 8. Not 9, so I know that, but so it's really hard to tell if it's between a 6 or a 7, right? Because you gotta have to estimate how much do you think that tree actually was in terms of height. So I would say either a 6 or a 7, but number 4 there is a definite 7.
It would be an 8.
And 8 is, well, so I would say it's a smaller tree, so it may be an 8. Once again, I would say 7 or 8. I would probably pick either of those. Because it is, if you look at the size of that tree, it's probably not very tall in general. It wasn't tall. It's not a perfect system. Just be close. 1, 2, 3, 4. So it's got live it's tricky, isn't it? It's got live vegetation, but it's lost its top probably in a storm. So because it's still alive, it would fall into number 2. All right. It's got actual green branches, so that tree is not quite dead. 1, yep. Tree on the left. 1, 2, 3, 4. And I got you all on that one. Look at the top. It has live, it's still alive. Yeah.
So it's a 2.
I would call it 2. That actually, it is the very top's alive. So, yeah. Won't be that tricky on the test. 4, 5, 6, 7, 8. So this is hard because you don't have any concept of where the tree actually ends. So if you were actually out there, you'd have a better grasp on it. One of the things I would say is, if I said this tree was spongy, would that change your thought on it? Yeah. Okay, so keep that in mind. 1, 2, 3, 4. It's somewhere between a 3 and a 4, probably closer to a 3. One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, very good. It is on the ground and starts transferring over to the CWD scale, which is not the deer scale. All right, that's it. Be a tentative to Canvas and sending out messages about lecture on Tuesday. I will send the Zoom link out to that if we have it via Zoom. If you don't get a Zoom link, assume we have class in person.